Thanks for having me. Hope you have some good energy at 4 p.m. in the afternoon. I'm going to be talking around IPv6 and web scraping and sharing some lessons which we've learned the last few years around this topic and how you can use IPv6 as part of your infrastructure for doing the scraping, the thing we need to do to get the data done. So a bit about myself. I am the CEO and co-founder of RapidSeedbox. The company has been live for 15 years. We've been involved in IP addresses and proxies for the last 10 years. And what started happening, I think, around 5 years ago, we started having a few clients coming and kind of asking us for IPv6. We didn't even have it anything advertised or offered anywhere. And it made me curious, like why? Like I was happy to accept the order, deliver, but then I didn't understand myself how IPv6 can be used effectively for scraping, or why they're using it, how they're using it. And really it made me digging, researching, and understanding the technical aspects of why and how it can be used. I think it's an unspoken topic a bit in the data extraction community, and there are valid use cases. So hopefully I'll share something that should be valuable and insightful. So I think I have two goals of the presentation. I want to share how IPv6 is kind of working right now globally in the world, because that's partially how the internet is built on IP addresses, and how IPv6 addresses may be practical and useful for your scraping infrastructure at the end of the day. So before I dive into today, I would love to cover a bit of the history. I think 3 great questions I love asking about every single topic is what didn't change, what will not change, and what will change. I have no idea what will change. I mean, things are changing all the time, 24/7. Things adapt, we need to change, but it's really good to focus on fundamentals. What will not change? What will still be here in a year, in 2 years, in 5 years, and in 10 years? And that allows you to design your scraping infrastructure and the strategy based on knowing what will not change while you're adapting on the go on things that change. So what didn't change? If we're going to go back to the fundamentals from the first day of the internet, there's a client-server model. So anytime you go and approach a website, there's going to be a bot, call it IP address. It sends a request to a server. It's very basic and fundamental. The server, the website, they process it. And then there's a response. You go back and you get a response. It's a basic, very naked layer of what didn't change on the model, on the client-server model. Now, this client-server model is built, to this day, on TCP/IP. So all the internet routing around the world works on the layer 3 of networking on a TCP/IP model. And that means every single request on the internet is going through either an IPv4 or IPv6. Every single thing, and it's covered by HTTP, HTTPS. There's a whole packet of how this protocol of the internet is built, and that's probably not going to change. Like in 10, 20 years from now, it will still be sending all routers around the world traffic around TCP/IP. Headers, cookies, user engine, payloads, everything is working with this transport layer, and then you start building on those layers. You have application layers, APIs, but everything is built on that on the more foundational level. So why you should pay attention to the IP addresses? I mean, in every website you're scraping, IP addresses are critical. There's an IP address behind it. Historically, it was mainly only IPv4s. Now, I know it's not the only thing which matters. There are more factors which start adding with the years, with the complexity of anti-bot and all the things which are happening to block the scraping, but the IP address, in my opinion, remains critical, whatever the IP address is, and it has a reputation, and the levels of IP addresses you choose are highly relevant whether your scraping will be successful or not successful. So the reputation of IPs and the addresses you choose are critical. It's one component of your scraping infrastructure strategy. If you have a bad reputation, a website may think you're spamming. It will not accept you. Or if you do too much scraping from one IP address and you're not rotating, like the IP addresses will matter, and you'll get blocked. So it's something to pay attention to. So why to think about IPv6 today and not in the future? First of all, you want to handle your infrastructure today. You want to make sure you're ready for 2026, 2027, the coming years. What happened with IPv4 in the world, it basically got depleted. So around a few years ago, the regional internet companies, they basically stopped giving more IP addresses. So there are no more new, fresh, virgin IPv4 addresses in the world. There are no allocations. There's only allocations reserved for large companies and very critical internet usages today. And there are big cost savings of potentially implementing IPv6 simply because of how IPv6 is structured, with the amount of pool of IPs you can get overall, and how you can structure the whole scraping around IPv6. So again, IPv4s are not getting more space, basically. It means all your infrastructure, which most likely is built around IPv4s, it's reusable IPs. They've been used to some capacity in the past. There's no such thing as an IPv4 which was not used. There is more expansion happening around the world with the internet, the data centers. So generally, the whole world of infrastructure is moving to IPv6. And I think it's important to understand because the scraping is still connected to the internet and all the other things. And the more you understand the whole picture, it will allow you to see how you can tackle it from a scraping perspective. So again, there are just simply no more unused IPv4 addresses. Well, that's not exactly the case with IPv6 addresses. So where does the IPv6 adoption stand around the world as of today? This was taken 2 months ago, but it didn't really change too much from September 2025. So this is from Google. 46% of all Google traffic in the world is already IPv6. Now, if you see the graph, the main adoption started happening around 2020. I think until that time, the internet was not the most IPv6 friendly in general. What it means is Google, I know there is lots of traffic going through AI right now, is still a big processor of the traffic of the whole internet. And most of our traffic is routed for IPv6. That includes our phones, the data centers, your residential. That's just how the world is built. It's still not 100%, so there's still lots of old devices, countries which haven't really switched to IPv6. So there's a dual stack situation right now where the world is working both IPv4s and IPv6s, but 46% is the big amount. Cloudflare is also roughly around 46 to 50%. And I don't know if and when it will get to 100%, but that's where we are standing today. So it is different by countries. USA is 50%, France is 80%, India is 74%, Germany 75%. So most of the Western and developed countries and the big ones in Asia where they have population, they're very IPv6 based because, again, there are no IPv4s. So the countries and ISPs are forced to switch it. The ISPs are doing dual stack. So maybe many of you in the house may use an IPv6, but in the end, there's going to be still an IPv4 connected to the IPv6 as well. And that's important to understand because when you go to a website, you want to understand how every website in the world interprets that traffic. So there's a regular user behavior behind it. Czech Republic committed to IPv4 stopping completely by 2032, but it's transition happening on the internet level in general. So one day or another, it's probably going to get there where the whole world will be IPv6. The question is when. Most of the websites in the world are IPv6 friendly. So the biggest ones, so it all depends on which websites you need to scrape, what's your target website, but the biggest one in the world are friendly. That means traffic is accepted when the IP address behind it is an IPv6 address and not IPv4. So why to think about IPv6, how it's connected with scraping, how it can be useful for your data extraction. I think the cost savings is one interesting component, simply because IPv4s are not cheap. Proxy infrastructure is built on IPv4s. You can build proxy infrastructure on IPv6s. But IPv4s is getting more expensive because it's supply and demand. It's basic rules of economy. The supply is limited, but demand is only going up and up and up, with all of us here in the room needing to do more data extraction. And there's a fairly early mover advantage when it comes to IPv6, so it may be used for some use cases. I don't think it's relevant for all, and that's a thing in the area worth considering. So let's get into some basics of how IPv6 actually works. So I love this quote from Sun Tzu. It's a great book, Art of War. If you know the enemy and know yourself, you need not fear the results of 100 battles. Now, I know I'm using the word enemy. It's more metaphorical word. I don't think there are any real enemies here. But the more you can get in the mind of so-called the enemy, and in this case, it's the website you're trying to scrape, the more you know and understand how the website is interpreting your traffic and data, the more you can adjust your scraping techniques, and you just know what they do, so it gets your job easier to do. So the websites and anti-bot systems is so-called the enemy in this case. And you have the scraping infrastructure, which is yourself. There's going to be, again, some server, some IP behind any request. It's just a fundamental of any infrastructure. So how do websites interpret and see IPv6? I think that's where it gets interesting. Websites don't ban single IPv6 addresses. They block 48s. What does it mean? Let me explain it. So for IPv4, let's say I have one IP address. You enter a website. They know it's one IP address. If you do it again and again, they're going to just block you, because that's how they interpret it. So if you have a range of 200 IPs, it's 200. With IPv6, a single 148 range has 1.2 septillion IP addresses. I don't know how to frame it. However, Google and many websites interpret it as one IP. And I think that's one mistake where people that wanted to try and use IPv6 for scraping fail. They think they can take a single 48, and they think they're kings of the world because they have septillion IP addresses, and you can't get any scraping done. It's just not realistic. Maybe you can get one request going, but it will never be really effective for any meaningful business or large-scale scraping project. So I think that's one big differentiator with IPv4 and IPv6. And again, there's so many IPv4 addresses, and that's just for a 48. If you go to a 29, which is a range of IPv6, it has 500,000 of 48 networks. So if you multiply 1.2 septillion by 500,000, you get lots of IP addresses. However, it's not really like you have septillion IP addresses, because if you would have a septillion IP addresses of IPv4s, you would have a good amount of infrastructure to scrape the web, but clearly there are even not that many IPv4 addresses in the whole IP pool in the world. So if you are rotating and you're using IPv6 48s, even though any website will interpret the 48 as one IP, you can still use the same IP a few times, but to be even safer, because they want to create a distance from each request you're sending, which will mimic more real user behavior. It will make sure the websites interpret you in a more real way. You want to rotate inside of 48s different 64s. And the value you're getting with IPv6 addresses, there's so many of them. So maybe it's not as effective where with IPv4s you want to use every single IP address. You have so many 64s, and that will reduce of any chance of the IP being banned. So inside the 48, when you're rotating inside of it, you want to set it up with 64s. That will help you isolate the jobs and prevent any potential blocks. And if you're getting a single 29 for the IPv6 ranges, you want to get the scraping jobs among different 48s. So imagine, as I said, a 29 has 500,000 48s. You even want to distance them more. Because you have such a big pool of IP addresses, it may give an opportunity to distance the scraping and requests from the IPs, and that's what will allow for a successful scraping request at the end of the day. For any serious or the most smallest scraping project, probably a minimum of a 29 block is what you want to take, and start breaking it down to smaller segments, small IPs basically, and start testing from there. If you can actually get scraping efficiency, if you can actually get success rate. But that's really where you have to start. I think that's the most minimal block size where you want to play and test. I've also a few practical implications. I think the next thing is configuration. The way you set up the IPv6 is slightly different than IPv4's. And you can take the same infrastructure, the same IP pool, but your request will be denied, and you think this doesn't make any sense, so you go back to everything else you're using. So configuration really matters as well, on top of everything. So what are a few things you want to set up in a correct way, which we found out, at least it's relevant today. This may be different tomorrow or in the future. Those things may change. So entire 48 as a single IP, that's one thing you may want to think about. You want to do sufficient amount of separation between the 48s. This will mimic a more real user behavior, because if you enter again into the head of a website, and if they see a single IP doing lots of requests, they're going to block it very quickly. It's just a natural website request. You want to rotate IPs regularly. And again, you don't treat IPv6 similar to IPv4 in terms of like one IP per machine. You just break it down, and that's still, you have enough of those blocks where you can set it up. And if you treat it as a single IP, that will not work. So serious scrapers start 29. Just test it out, see if your website, if your target use case is relevant. You want to make sure all the proxies you're setting up on the IPs are binding correctly to the IPv6. And that's an interesting one, which we found out. You need to set up reverse DNS delegation per a single 48. That's optional, but apparently we had a few requests which were being blocked when there was no reverse DNS. So for those that don't know what is reverse DNS, usually you use it for mailing purposes. You have to set it up in the Internet Regional Database and name server per each IP block. And it's more used on the email protocol. When you set up your regular proxy infrastructure with IPv4s, that's not a requirement. I mean, it's just really not needed. Apparently, when you add it up right now, some services just pass the traffic more smoothly. My guess is it adds some trust signal because there's so many IPv6 addresses, and maybe they address like what will happen in terms of scraping, and someone will start scraping. So it's something they're checking. It's a very low-hanging fruit. It's a configuration issue, and this will help ensure the traffic gets through smoothly. Yeah, so those are a few things you want to do on configuration. Now let me ask you a question at the end of the day. Do you really care about IPv6? I guess the answer is no. You don't really care about it. The only really question you should be asking yourself is effectiveness of your scraping infrastructure and what are the costs? I mean, we all have businesses to run, and those two are critical components. If IPv6 may be relevant as part of the component, consider testing it. Other than that, I think that's the only question you should be carrying for your whole scraping infrastructure in terms of reliability and getting the job done. That's all I have for you today. Thank you so much.